كده قبل الشغل نتفق عليهم وندفع عقلون.
شغل البطاريات شغل الناس ده بلاقي تقدر تشتغل في حق السيطرة
مش هيتدفع الويس.
بالله والله لكن دي فكرة كويسة.
يعني
Hello, could you please mute your voice?
الليلة لما في السودان الناس دول ما تقول مع بعض.
Hello.
بس بيدرسوا كده كهرباء يا برمجة. وقال لنا في السودان بس هيستوري حقها بس. حتى ما بعرفوا يعني قال لنا إنه عنده الناس دول كهرباء في السودان ولما مشوا اشتغلوا برا. إلا عادوا قالوا من
بالله.
قال لي لو ده تقرا بابا قالوا لنا.
Hello, good evening, everyone. So welcome to the new session of our course. Today's session will be about the physical optics, physical and geometrical optics. So I hope that you have already cleared the anatomy, so you don't have any lag for your study. And today's lecture can be considered one of maybe one of the most challenging lectures, given that it discusses the physical and geometrical optics, which is by nature, it's a tough topic. So I encourage you all to read it once and twice and listen to the lectures more than once, because it is unlikely that you will grasp all information present in these lectures from just a single reading or single listening to these lectures. And of course, the discussions or the lectures, the questions lectures will be of extreme importance to just make the questions ideas more clear to you. So let me share you my screen, and to start with the first question of optics. Hold on. Okay, I guess that you can see the screen now. So let's start immediately with the first question. So I'm going to share you the question and let me know what are your thoughts about it. And please respond in the chat box with the answer if it is true or false in your opinion. So let's start with a question about the prisms. So regarding the prisms, which one of the following statements are true and which are false? A prism can be used to measure fusion amplitude. What do you think? Is correct or wrong?
Right.
Any other answers? So doctor who said correct, can you please tell me what is meant by fusional amplitude?
It's difficult to
Explain,
explain.
yeah, I know.
Yeah.
Okay, no problem. I will explain later. So does anyone have any other answer? Do you all agree that prism can be used to measure fusional amplitude? I guess so, and this is a correct answer. A prism cannot be used to double an image. What do you think? It's correct or wrong?
Wrong.
So, any answer?
It's wrong, sir.
Wrong.
It's wrong, yeah, exactly. It's wrong. So, can you give me some examples where a prism can be used for doubling the image? What are some devices? I know that we didn't reach that far yet. However, these are asked in the physical and geometrical optics questions, unfortunately. So we have two special devices or two main ophthalmic instruments that use prisms as doubling devices.
Indirect ophthalmoscope.
Indirect
Tonometer.
No, it's not by indirect ophthalmoscope. Tonometer,
Tonometer.
yeah, that's the one, which is the Goldman applanation tonometer. And what else? We have also the old pachymeter, which used to be a slit lamp attachment. So this has also used this principle of doubling an image. Also in the instruments lecture, we will discuss keratometers. The keratometers also use prisms as for doubling the image. So we will get back to that at the end of the optics, but just wanted to mention those because they are asked frequently in the physical and geometrical optics. Okay, the third question, a prism diopter equal 2 degrees of angle of deviation. So what do you think? It's correct or wrong?
Correct.
Yes,
Right.
exactly.
Right.
Correct. This is the principal law for measuring the power of the prism, that one prism diopter will be equal to half of angle of deviation, or one degree of angle of deviation, or the two prism diopters will equal one prism diopter will be equal to degrees of angle of deviation. Okay, a prismatic effect can be induced by decentering the lens. Is that
Correct.
Right.
correct?
Yes.
Correct.
And
Right.
what is the
Correct.
name of this rule?
Right.
What is the name of this rule?
Prentice rule.
Prentice rule, exactly.
Prentice
Prentice rule for
rule.
decentration. A prism can be used to make a spectrometer. So this can be a rather bit difficult question because maybe many of us don't know what is a spectrometer. So can you give a guess?
Fossimeter.
Yes, it can be used for
Fossimeter.
fossimeter the prism. I don't think so. No, prism is not incorporated into the fossimeter. But anyway, the question here is asked about the spectrometer. So the spectrometer can be used, a prism can be used in it. This is a correct answer. So let me give you some explanations about the options present in this question. So as we just mentioned, what is the fusional vergence and the fusional amplitude? We will get back to that, or we will get to that in the physiology lectures, especially in the class of the binocular vision. So a fusional amplitude and the fusional vergence. Let me just give you a simple demonstration. When you are approximating a pen towards your eye, you will see that the image is seen as a single. However, as you are coming more close to your eyes, you will suddenly find that the image becomes double. And why did the image of the pen become double? Why do you see two pens instead of one pen? Because now your fusional vergence is less than your fusional, or the fusional vergence is less than the fusional amplitude needed. Meaning that it is like the fusional vergence is the movement of both eyes together. in order to make fusion of the monocular images to see a binocular vision. So whenever we have an eye like that, and this, so when you have a pen like this and you are approximating, you can see that both eyes will be converging. This convergence or this amplitude that makes the eye see this single image, or so this eye see one image of this pen, and this eye will see another image for this pen, and both eyes can cause fusion of these two images in order to produce what's called binocular vision, single binocular vision. But what happens if we are just approximating each more further and the eye is now more converging? And this convergence can be calculated by the prism diopter, because it's just a movement of the eyes toward each other. So it can be, this movement can be neutralized by prism diopter. So the fusional vergence is the movement of both eyes to enable the fusion of the monocular images to produce binocular vision. And this can be different according to the kind of movement itself. So for the convergence, it will be the maximum, meaning that it will be about 15 prism diopter for far and 25 prism diopter for near. For the divergence, theoretically, when the eyes diverge, they see double images. But since we have some fusional vergence for divergence, we don't see this double image. And this will be 6 diopter for far and 12 diopter for near. The vertical fusional vergence is much more limited. It is only 2 to 3 prism diopter, and for the cyclodeviation, it is only 2 to 3 degrees. And let me give you a practical example for this limited fusional vergence in case of vertical movement. So let me just erase all this. So just to check this picture, which one is more annoying to your vision? This image number 1 or image number 2?
Number 2.
Number 2. Why? Because you have a great fusional vergence for the horizontal movement. So you can fuse these horizontal fingers more easily than you can fuse these vertically displaced eyes and these vertically displaced mouths, because you have a limited fusional vergence for the vertical direction. Okay, so you can see that we can now measure the fusional vergence and amplitude. So this amplitude is different according to our age. So like, for example, the vertical fusional vergence and amplitude is larger for children than for the adults. And this is one reason why those who had trauma during their head during childhood and they had fourth nerve palsy, it become decompensated later on in after 20 years or 30 years. This is because they have decreasing their vertical fusion and they can no longer compensate for this increasing heterotropia and for the vertical heterotropia that they suffer from. So this is just one application for the fusional vergence and the fusional amplitude. But anyway, just for the sake of the basic exam, we need to know that it will be measured by prism diopters. So the question is correct. The second important thing about the question is what's called the imaging doubling. There are certain prisms used in ophthalmology and in ophthalmic devices that produce doubling of the image. So this doubling of the image is crucial for the working principle of the device. Specifically, two of them are the pachymeter. This pachymeter is like a very old device. I remember that I used it in the slit lamp during my residency more than 10 years ago. So it is no longer available now in routine clinics. So this device is used the principle of image doubling because it has incorporated a prism. This prism will cause a doubling of the corneal beam section, as you can see this. And your rule is that you're just approximating the inner edges between the two double images in order to reach the correct orientation so that you can measure the reading here, which will give you a clue about the corneal thickness. That's why it's called a pachymetry. Pachymetry is the measuring of the corneal thickness. The second device is the Goldman applanation thermometry, in which there is a cone. This cone has prisms. These prisms will cause also doubling of the image. So what is the image? It will be the imprint of this circle over the cornea. So if there is no prism, it will show when you are checking the measuring of the intraocular pressure, you will find just a circle. However, this prism will cause doubling of the image. So it will divide this circle into two hemicycles, and your rule is to approximate the inner edges of these two hemicycles in order to reach the correct intraocular pressure measurement. Okay, so these are two important application of prisms in the image doubling. Another application will be the keratometer, and this will be discussed in more in depth in the instruments lecture. Would you please mute your voice if you are not participating in the discussion? I had to mute you all. So please, if you are participating in the discussion, just unmute yourself. Okay. The third important point is the notation of the prisms. So we mentioned that the prism can be measured by, or the power of the prism can be measured by different methods. The most commonly used is the prism diopter. However, there are other methods such as the centroid, which is slightly less than the prism diopter. Also, we can measure it by apical angle or angle alpha, or the angle of minimal deviation. So one prism diopter roughly equals one centroid, which equal 1 degree of angle of minimal deviation, 1 degree of apical angle, and 2 degrees of the angle of minimal deviation. The third thing that we mentioned before is the Prentice rule. So whenever we have a spherical or a cylindrical lens in front of the eye, and we moved these lenses either up or down, temporal or nasal, then the light ray passing through this lens will not pass through the center of the lens, but it will pass through the periphery of the lens. And in this case, it will suffer from a prismatic deviation, because we know that the light ray are deviated toward the base. So in this case, when we are decentering the spherical lenses, we can just having a base up, base down, base in, base out prism in front of the eye, so that the light rays will deviate accordingly. And this can be measured by the Prentice rule, in which the prism deviation in prism diopter will be equal the power of the lens multiplied by the decentration in centimeters. Finally, what is called the spectrophotometer. So a spectrophotometer, it is a device that measures the light intensity. It will measure the light intensity of a single monochromatic light. Like if we have the light, it is like a measuring of the wavelength. Sorry for that. It measures the wavelength. So it can calculate how much the specific wavelength of the light is available. So whenever we have a light source, this light source is polychromatic. So it will come to a collimator lens to just make this divergent light come together into a single focus. Then it will pass into a prism or a grating. So a prism is used here in the spectrophotometer in order to make dispersion of this polychromatic light into single wave or monochromatic lights. Then this dispersion will cause dispersion, or this prism will cause dispersion of lights according to the wavelength. and then light will pass through a wavelength selector. So for example, if we want to measure the intensity of the yellow light, so this wavelength selector will be adjusted according to the wavelength of the yellow light, and then it will pass through a sample solution or aqueous solution. Then it will pass into a detector like a photocell, which can convert this amount or this intensity of light into a digital display. So we can know how much is the intensity in numbers. So this is the principle of the spectrophotometer. It is just measuring the light intensity as a function of the wavelength. Okay, and it utilizes the prism as one of its components. So I guess we have everything clear about this question. So let's now check the other questions. These questions are tough, so I know, I understand. And even this was like an old exam of the ICO, so, and they clearly mentioned that these questions are difficult to answer. Okay, so for the next question, it is about the polarized light. So regarding the polarized light, which one of the following statements are true and which are false? It may be produced by the anisotropic material. So I know that this concept or this term may be the first time to encounter, but can you give me a guess?
Wrong.
Okay, so
Wrong.
does anyone know what is anisotropic material?
Something which is not isotropic.
This is funny. So this is as if I'm asking what is white, something which is not black. Okay. Okay, smart answer. Okay, no, I will explain to you what is meant by anisotropic, but let me just tell you that this is a correct answer.
Okay.
The second one, it may be produced by gases. So is it correct or wrong? Could a polarized light be produced by gases?
Probably.
Maybe, I agree, that could be correct. Could it be explained by the wave theory of light?
True.
True, that's exactly. And it cannot be seen with the monochromatic light?
Wrong.
Wrong. Actually, the monochromatic light is almost always polarized. It may be observed in the human eye.
Wrong.
Yes. Correct.
It's correct, yeah. So these are all regarding concerning the polarized light. These are some options or some properties of the polarized light. Let's go in depth in more details. So first of all, what is meant by the anisotropic material? When do we call a material is anisotropic? This means that a material is called anisotropic when it depends, or the properties of this material depends on its direction. Again, anisotropic material, aniso means different, tropic means shape. So the material, the characters of these materials are dependent on their shape. Let me give you an example. This piece of wood, you see it? So you can see that this piece of wood, it has lines, like horizontal lines like that. Let me give you an example, or give you an example. If we have an axe like this, and I try to cut this wood parallel to these lines, so I will say that this is a position number 1. And I try to cut also this piece of wood with this position number 2. Which one do you think will be easier?
1.
2.
1.
2.
1 or 2?
1.
1, exactly, because I am in line with these parallel lines. So the piece of wood will split easily. However, if I try to cut them perpendicular to these lines, this will be difficult because there is no line of separation vertical. And this means that this piece of wood function or this piece of wood properties is dependent on the orientation or dependent on the direction. So the same thing happens with a lot of, this is like a physical property which appears in many other compounds in the nature. So some compounds are isotropic in nature. So whatever orientation you put this material, there will be no change in the behavior or in the character. Or other compounds, other structures have an isotropic structure or anisotropic properties, meaning that the function is dependent on the orientation or the direction. So one of these materials are called the anisotropic polarizers. So anisotropic polarizers are the anisotropic polarizers are materials when they are put in certain direction, like these crystals have certain direction, and when we are putting them in front of the lens, they can act as by birefringence, they can cause polarization of light. So to get back or to return back to the question is asking about, could the polarized light produced by an isotropic material? The answer is yes. Okay, let's move to the next one. It can be produced by gas. Yes, this is another phenomenon called the atmospheric polarization. So the atmospheric polarization, meaning that even the air present in the atmosphere can cause polarization to the light coming from the sun. So when we have sunlight here, this is the sun producing the light rays, and these light rays are coming to a particle, dust particles present in the atmosphere. These, we said before that these dust particles will cause scattering, and this scattering will also cause polarization. So it will cause some vertically polarized light, some cause horizontally polarized light. So not only the particle will cause scattering of light, but it will also cause polarization of light. And this scattering and polarization is more toward the blue spectrum of light. That's why the sky appears more blue because of the scattering and because of more polarized light in the blue spectrum, which appears more clear. That's why the skies appears more blue. The wavelength of the light is also one of the theories that explain the polarization. So we said before that we have three main theories of light: the electromagnetic spectrum, the wave theory as the light is traveling as waves, and the particle theory as the light is traveling as particles. So you can see that the wave theory can explain the polarization because the light has waves that are propagating in different directions, and when they encounter a polarizer, they will transmit only waves of the parallel direction to the transmission axis. And this means that it is only single kind of waves, or it will allow only single type of waves to pass through this polarizer. However, the particle theory cannot explain the polarization, because if we are just assuming that the light is passing as a particles and these particles are encountering a polarizer, well, these particles will pass on the same direction. The polarizer will not affect or will not stop the particles. So this cannot be used to explain the theory of the polarization. It can be explained by the wave theory. And this is just a summary of what physical properties of light can be explained by which theory. So the wave theory can explain the polarization, can also explain the reflection, and can explain the diffraction interference, and can explain the refraction. The particle theory can explain, these are some not important theories like photoelectric or Compton effect, but it also, the particles can be explained by the reflection and refraction. The refraction of light or the monochromatic light is almost always polarized, meaning that we know that whenever we have a polychromatic light that consists of different waves of different wavelengths, and they will pass through a polarizer, then they will this polarizer will allow only the light waves propagating into one direction. But if we have already a single monochromatic wavelength that is already has a certain propagation through the electromagnetic spectrum, and usually these are polarized by nature, and usually so the question is asking that it cannot be seen with the monochromatic light. No, actually the monochromatic light usually can be seen as propagating in a one-way direction. Finally, the question is asking about that it may be observed in the human eye. Yes, it can be observed in the human eye because of an important phenomenon called what's called the Heidinger brush. So we mentioned about it before, and we said that the Heidinger brush, it is the ability to see this pattern, which is like a yellow bar appears like a bow tie with fuzzy edges. So this yellow bar or with fuzzy edges, this is caused by this can be seen by polarized glasses by the human eye. This is because an intrinsic structure present in the human eye, and this is the xanthophyll pigment. So the xanthophyll pigment contains some yellowish pigments present in the macula lutea. And it was thought that the Heidinger brush is caused by the xanthophyll pigment present in the fovea. So it can be observed in the human eye. Okay, so I hope that this question is clear now. And let's now check the next question. So I'll give you just maybe a minute or few time to read it, or maybe to think a little bit about it. Okay, so the deviation of a ray of light passing through a prism made of precision glass, which has a refractive index of 1.55, is minimal. So the question is asking what will decrease the deviation in the prism. First one, the apical angle of the prism is less than 45 degrees. What do you think? If we have a decreased angle of decreasing the apical angle, will that cause decrease in the deviation?
Yes.
Exactly. This is one of the factors that affecting the angle of deviation, or the amount of deviation. It will be the apical angle.
Twice the half of the apical angle.
Exactly. The ray traverses the prism parallel to the base. So is this one of the factors that are responsible for the deviation?
Yes, they are, and this is, but this is wrong.
This is wrong. Yes,
it's
it's
wrong.
One of the factors. The incident rays lies at the right angle of the surface. So let me just draw it to you. Like if we have a prism like here, and if we have like a prism that, or a light ray, incident light ray that has an angle of incidence, and then it will refract, and then it will deviate toward the base. But what happens if the light ray is perpendicular, or the angle of incidence is like 90 degrees? What do you think the deviation will be?
Less.
It will be less. Actually, it will be no deviation. It will pass as long as on its pathway. It will be passed vertical, because the light rays are in the angle of deviation depending on the incident angle. So if there is no angle, well, it will be no deviation.
Correct.
So this is the incident ray at right angle of the surface will be, the angle will be minimal. This is correct. The incident and the emergent rays are symmetrical about the prism. So is this factor that will cause the decreasing the angle of deviation? Like this to be like this, for example.
That will cause more.
It will be wrong answer.
That will be wrong also.
Finally, the surrounding media has lower index. So let's say, for example, that this is a crown glass of refractive index of 1.55, and this is air which has a refractive index of 1. Would you think that
wrong
is wrong? Exactly, because
it will cause more deviation.
If the surrounding medium has lower index, or if the refractive index of the prism has higher index, or the difference between both of them is large, then this will cause more deviation, because there is greater difference between the light passing in the medium 1 to the light passing through the medium 2. Okay?
More the difference, more the deviation.
Exactly. So this is based on the Snell's law of refraction. So the angle of deviation, we said before that if the refractive index of the glass is 1.5, then the angle of deviation will be equal the apical angle divided by 2. So here there is angle of incidence, and this is the angle of emergence, and this is the angle of refraction. And there are certain factors that will control the D, or the angle of deviation, this one. So what are the factors that will control the angle of deviation, which will control how much the light is deviated? As we mentioned before, the wavelength of the light. So if the angle of minimum deviation is smaller for longer wavelength, so light or the red light deviate less than the blue light. So the shorter wavelength, the more the deviation. Also, the material of the prism is directly proportional to the refractive index. You remember the last option in the question? It says that the decreasing refractive index of the surrounding medium, or increasing the refractive index of the material of the glass of the prism itself, will cause increasing the angle of deviation, because it will, the greater the difference, the greater the deviation. It is directly proportionate. The angle of the prism also is directly proportionate. The more the angle, the more the deviation. And the angle of the incidence also, it will control the angle of deviation, or it would affect the deviation. But if it is perpendicular like this, there will be no deviation. Okay, so let's move to the next question. I think that this will be an easy question now. The Goldman tonometer employs which one of the following principles? So diffraction, what do you think?
No.
No. Polarization of light?
No.
Optometric principle?
No.
I don't know what is optometric principle. Optical doubling?
Yes.
Exactly.
Yes.
Split field prism, I don't, it is wrong. I tried even to think to search about what is called by split field prism. I have never seen something like that, or something called split field prism, because I thought it could be right, because it is Goldman causing splitting of the image, but it is not called a split field prism. Okay. So you see the next question, the pachymeter. So I told you that those two devices, the employs principles are mentioned in the prisms, or asked in the prisms. So they tend to be asked in the prisms, not in the instruments section of the exam. So pachymetry can be measured by which one of the following methods?
Optical doubling. Optical doubling.
Optical doubling also. Okay.
Ultrasound also.
Ultrasound also correct.
Ultrasound also right.
Yes, exactly. So this is very important. Let's see again, the image doubling by the prisms can be done by the pachymeter, can cause doubling of the corneal section, and the Goldman applanation tonometer, it can cause doubling of the corneal image. And there, it is this pachymeter, or this optical pachymeter, let's term it the correct term, it is called optical pachymeter. It is an old-fashioned way to measure the corneal thickness. However, in the era of the refractive surgery, there are other much more reliable methods for measuring the corneal thickness. Most notably will be the ultrasound, or called the A-scan. So this not the A-scan. This optical pachymeter can be used for measuring the corneal thickness, and also we can use like the
OCT.
Yes,
Optical cornerstone.
we can call the corneal topography like this. So this map is called the corneal thickness map, and also we can use the anterior segment OCT.
Anterior segment OCT.
So these are the gold standard now for measuring the corneal thickness. Okay, so let's check the next question. So this question is like, it is, of course, all these are recall questions. So the question is saying that a rectangular aquarium is filled with a clear fresh water. Clear fresh water. And how will a scene present on the surface of the aquarium? Let's say, for example, that this is an aquarium and this is like the surface, which is filled with clear fresh water. And you see, like, for example, there is a fish. Consider it like a fish. And this fish is present on the surface of the water. And you are standing here looking into the fish. So how does it look like? It is closer and larger? What do you think?
Yes.
Exactly. Closer and the same size? No. The same distance and the larger? No.
False.
No.
Just concentrate here. It is less clear?
Yes. Less clear.
Less clear. Do you believe that it will be less clear? Since that we are standing looking at this fish in a clear fresh water, and I am standing in the air. So this will be discussed in the human optics, but let me just tell you now, it is not less clear, and it will be more clear than if you are standing in the water, and I will explain to you why now. Closer and smaller. Oops. This is not
false.
False.
False, yes.
Closer and larger. Okay.
So let me fix it. Okay, so closer and larger, closer and same size, same distance and larger, less clear, no, and closer and more smaller. This, oops, sorry. This should be wrong. I don't know why I changed it to right. Okay. So let's have explanation. So we said in the reflection and refraction lecture that when we have objects immersed in the water, then they look more close than they really are because of the refraction. So light coming from the sun to this fish will reflect from the surface of this fish, then it will deviate to come to the water. And since that the light rays are coming from more dense to less dense, they deviate away from the normal or away from the perpendicular plane, and then they will come to the eye. But the eye cannot see in this broken line, and we will come to this principle in a while after just a few questions. So there is a principle why the eyes cannot see in a broken lines. but the eye can see only in the shortest available distance. So the eye will see a virtual image of this fish, which appears more closer to the surface and also more large, because whenever the object is more close, it will become more large. And we said that in the magnification lecture. So we said that if you are looking at the moon and you are standing and holding a coin in front of your eyes, you will find that the moon will obscure, the coin will obscure the vision of the moon. Does this mean that the coin is larger than the moon? No, but because it is just closer to your eye, it will make a larger angle at your nodal point than the moon does. Regarding the clarity of the object, so what will be more clear if you are standing in front in the aquarium, or you are opening your eyes in the aquarium, so there will be water in front of your eyes, or if you are standing out of the aquarium and you are looking to the fish. Actually, this will depend on the difference in the refractive index, meaning that this will be covered in the first lecture of the human optics, that when this is the cornea and this is the air refractive index is 1, as the air refractive index of the cornea is 1.376 as far as I remember. So there is a great difference between the refractive index between the air and the cornea. This will cause more bend of the light, causing more clear vision. However, if we are standing in like a swimmer opening his eyes in the water, in front of the cornea will be water, which has a refractive index of about 1.3. So there will be like very minimal difference between the cornea and the water, causing the vision to be blurry. So how does a swimmer overcome this blurriness? Just by wearing some goggles, swimming goggles. If you are wearing swimming goggles, now you have air in front of your eyes, so you restored the corneal air interface, causing the vision to be more clear under the water. So I believe that this is the trick in this question. So and even the question is asking is telling you that you are standing in front of clear fresh water, so there will be no scattering of any light by any particles present in the water, so which can cause degradation of the image quality. So it will be clear since the water is clear and fresh, and there is air cornea interface, then the image will be clear. Okay, another question about the polarizer. Concerning the polarized light, which one of the following statements is most likely to be true and which are false? Polarized light is safer to see than the unpolarized light. What do you think?
Wrong.
So the unpolarized light is safe?
No.
If the unpolarized light is safe, why do we find that the glasses shops selling us polarized light, polarized the glasses?
Polarized are more comfortable. Maybe not safe. It's not about safety, it's about comfort, I think.
So let's say that it is, if you are now wearing a polarized glasses in the road and you are driving, it is safe to wear polarized glasses or not? So, well, I think that it's
Yes.
correct. I think it's correct. I will explain to you in a while. The transmission axis of a wire grid polarizer is parallel to the axis of the grid as depicted in the figure below. So if the light is vibrating in all directions and it is now passing through a grid which has its wires horizontally oriented, then it will pass only the horizontally directed waves.
Yes.
Yes, exactly.
Hmm.
The sky observed through a polarizer can appear bluer because the blue part of the spectrum is the least polarized. I have just mentioned that.
More polarized.
Yes, it is more polarized. This is the correct answer. So it appear more clear. Sorry,
But least
it is least polarized.
wrong.
This is wrong.
Wrong. That's wrong.
Okay, let me just correct it. The birefringent material affect the light differently. It should be affect, not effect. Affect the light differently depending on the polarization. This, like, I don't understand really what does it mean by this answer, but I think that it is just written wrong, because the birefringent material affected the polarization, or the polarization of light, or the birefringent material affected the light by its birefringent properties, not by polarization, or it will cause polarization by its birefringent properties. So there is something which is not well formulated in this option. But by this option, or birefringent material affect light differently depending on the polarization, no. It is the polarization is what is dependent on the birefringent materials. So here is a question: which is more safe? This is how does it look with the polarized light, and this is how does it look with the non-polarized light. And this is how I think about this question. When you are wearing a spectacle, the sunglasses, or the sunlight is reflecting from the road like that, and also reflected from the water or any horizontal surface. So when you are looking to these reflections from your without polarizer, then this unpolarized light will cause glare, can cause discomfort, as you said. But it is not only that; it can be sometimes not safe if you are driving over the road with this much reflections. Then you maybe can miss a bump in the road, can miss any obstacle present in the road. I believe that it will be less safe to see just unpolarized light.
Yes.
The wire grid polarizer, as we mentioned, this is the simplest polarizer, and it consists of a regular array of fine parallel metallic wires that are placed in a plane perpendicular to the incident beam. So these are this beam. The beam is like perpendicular to this parallel grid, or this polarizer, and it will allow only if according to the transmission axis. If it is vertical like this, then it will allow only the vertically polarized wave light, which is the same, or the light emergent from it will be parallel to the transmission axis of the wire grid polarizer. Regarding the blue spectrum, so we said before that the blue sky appears blue because the particles present in the sky will cause more scattering of the blue end of the spectrum more than the red. And this is the case also with polarization, as we mentioned in the previous question, that these particles will cause polarization of light, and this polarization will be more in the blue spectrum than the other. And you can see even in the question itself, the question is not asking if the light is polarized or not, but the question is asking which will be more or least polarized. So you can understand even from the question that the light is polarized, or the sky is blue because of polarized light. But it is which one which is more polarized? Is it the blue or is it the red? Or is the blue is the least polarized, or it is the more polarized? So as we can see, it is the more polarized. Okay, so the final part, or the final option, yes, we missed that. Light from the liquid crystal display is polarized. This is correct. So the liquid crystal display, or the LCD, are dependent on the polarized mechanism. So they are polarizers used in the LCD technology. And finally, the birefringent materials are some materials that has the property of birefringence, and this birefringence can cause polarization of light. So whenever an unpolarized light passes through one of these birefringent materials, such as the co-polarizing prism or the Wollaston prism, they will undergo splitting of the light into polarized lights. Okay, let's now check the next question about physiological optics. The resolution of the emmetropic eye with the 2 mm pupil is limited by monochromatic aberrations.
No.
So what will be the limits of the visual acuity of a pupil with this size?
Diffraction.
Diffraction, okay, correct. And this is like a question that I'm asking, which will be like before its time. But what will be the limits of visual acuity of emmetropic eye, or if we have a larger pupil, like about 8 or 10 millimeters?
Spherical aberration.
Yes, it will be the aberrations. So the aberrations occurs in larger pupil, or it will degrade the visual acuity in larger pupil. However, the smaller pupil will cause degradation of the visual acuity by the aberrations. Okay. The next one, the crystalline lens absorb more 400 nanometer light than the 500 nanometer, or more toward the shorter spectrum or the bluish spectrum than the reddish. So what do you think?
Wrong.
What kind of ultraviolet rays? This has been explained in the questions lectures and the topic selections. So what are the kind of light rays that is absorbed by the lens?
Ultraviolet A.
Ultraviolet A. And what is the wavelength range of ultraviolet A?
Less than 400 nm.
Yes, so it will be less. So it will be more toward the lesser spectrum than the larger spectrum.
Yes.
The Stiles-Crawford effect can be asymmetrical in myopia. So this also will come in the next lectures. So what is meant by Stiles-Crawford effect? I know that you didn't come to that point yet. So the Stiles-Crawford effect, meaning that it is an effect of the effect of light when it is hitting the photoreceptors in the perpendicular plane or obliquely. Meaning that if we have, this is the pupil. Let me just erase this. If this is the pupil and this is the retina, and we have here some photoreceptor like some cones like this and this. When there is a light that is hitting the cone perpendicularly, will cause maximum stimulation. If there is a light passing through the pupil obliquely and hitting the cone obliquely, this will cause decrease of the stimulation. So the photoreceptors are more responsive to the light that hits them directly rather than the light that hit obliquely. So what happens in the myopia? The myopia, everything is large. The cornea is large, the sclera is large, the pupil itself is large. So the larger pupil, which can sometimes be asymmetrical, can allow more oblique light to affect the retina, causing the Stiles-Crawford effect not to be symmetrical in all cases because of the larger pupil, which sometimes can be asymmetrical, as anything or any structure in the eye can enlarge asymmetrically. The fovea of hypermetropic eye is closer to the optic disc than the emmetropic eye.
Correct.
Wrong.
Well, actually, I tried to search about it for a lot, but actually I don't have a conclusive answer. But I believe it is most probably it is wrong. So, but I tried to look for it in many resources, but I couldn't find a clue about it. But for me, I believe that it could mostly it is a wrong answer. I don't feel comfortable with this option because it looks like a correct answer, but actually this is not how the ICO present their questions. But let me also try to look for it more and more. Maybe I found a resource or any reference that can state it in more details, and I will let you know. Finally, the final option is about also something that will be discussed in the coming lectures or about the human optics, which will be the angle alpha. Angle alpha in the myopic eye is smaller than in hypermetropic eye. What do you think? Hello? Anyone?
Larger. It will be larger.
It is larger, yes. So,
Yes.
so that's why I'm telling you that this is how the ICO think. So they brought you a smaller with the myopia and brought you closer to the hypermetropia. So this seems like a logical answer, but this is wrong. And this is myopia is smaller will consider can be logically it should be wrong. However, it is right. So the ICO is trying to trick you. These are like question tricks. Okay, so the lens absorbs the ultraviolet A rays, as you mentioned, and the ultraviolet A range is between 320 nanometer to 400 nanometers. So it is not 500. This is totally wrong. And the style graph for the effect, as I mentioned to you, it is that the response of the cones or the photoreceptors to the perpendicular light is more prominent, the more pronounced than the light hitting the retina obliquely. So this will be more happens more frequently with the myopia because of the larger pupil and the more tendency for the oblique light to pass through it. This will be discussed in the lectures, but just to a sense that it will be asked in this question, let me brief you about it. The optical axis and the visual axis. So the optical axis is the axis which will pass through the center of ocular structures, like center of the cornea, center of the lens, and the nodal point. This is called the optical axis. On the other hand, the visual axis is called the visual, so it is related to vision. So it will pass through the fovea, the nodal point, and the object of interest. The angle between the optical axis and the visual axis, it is called the angle alpha. This angle alpha is present at the nodal point here. And it is normally in the emmetropia, it is about 5 degrees. This is the visual angle. It's becoming positive or more than 5 degrees in the hypermetropia, and it is becoming negative or less than 5 degrees in myopia. So in hypermetropia, they are larger than the myopia. And this can be easily explained by this diagram. So if we consider that the red line is the emmetropia, so here, and this is the angle subtended at the nodal point, the hypermetrope will be here, so the angle of hypermetropia is larger. And this the myopia, this is the elongated eye of the myopia, and it will show on the black line, and you can see that it will be smaller. This is only for the myopia. So again, angle alpha is larger for the hypermetropia than the myopia. And I guess also this can this diagram can also explain the previous question in which the asking about if the hypermetropia, the fovea appears closer to the optic disc. We can see from this diagram that it is not, causing larger angle alpha. Okay, next question about interference. So regarding the interference, it results from the superimposition of waves.
Correct.
So what will be the net result of the superimposition of waves? What kinds of interference that could happen?
Constructive or destructive?
Constructive or destructive, exactly. Okay, occur only if the two light waves have similar phase.
Constructive.
It's
Not
constructive,
only.
but not only, yes, because destructive can also occur.
Maybe,
Not only
maybe in
wrong.
phase or out of
Yes.
phase.
Yes, exactly. It produces a pattern of ring when the light is passed through 1 millimeter circular aperture. Just concentrate.
No.
So what is the
Diffraction.
I agree that it is no, but
Yes.
what is the wrong thing here? So why this option is wrong?
It is not a pattern of rings. It is not a rings.
Exactly. So what is called? Here is the trick.
Waves.
Interference.
Yes, it will cause
Fringes.
interference rings, but it is only rings. Did you hear about Ayres disk?
Yes.
Yes.
So when there is Ayres disk is caused by interference happens when the two sources of light pass through small circular apertures, causing patterns of rings, but these patterns of ring are surrounding the disk. So it is a disk, dark disk, or a disk of light surrounded by rings.
Yes.
It is not only a pattern of rings. It can be used to increase the light transmission through the optical system. No, this is not true.
Yes.
And it can be used to measure the retinal contrast sensitivity. Also, this is a
No.
Wrong.
Okay, so as you all mentioned that the superimposition of waves, superimposition meaning that it is like a general term, meaning that there are two waves are becoming more together in the same place in the same time, and they are reacting to each other. So they will cause interference causing a single wave. This interference can be constructive interference, meaning that since that the light wave of the first wave or the top of the first wave is coincident with the top of the second wave, and the trough of the first wave is coincident with the second wave, then the resultant wave will be the summation of both waves, which is called the constructive interference. However, if there is difference between both waves by half of the cycle, meaning that the top of the first wave is corresponding to the trough of the first wave, then they will cancel each other, causing what's called destructive interference. So both of them are patterns, specific patterns of superimposition of waves, which is like a broad statement or general term. When the two lights from two sources join together, they will cause patterns, they will cause constructive and destructive interference. And these patterns of destructive and constructive interference will result in what's called Ayres disk. In the Ayres disk, there will be a central circular disk, which is bright, surrounded by alternating dark and white bands, or the alternating dark and light rings. So this is the pattern of rings which happens when the light passes through a small circular aperture. It is a central disk called Ayres disk surrounded by alternating dark and white rings. Okay, next question. So this question about ray optics or the optics of rays, light rays. Fermat's principle states that the path taken by the light ray is the path of the least time. What do you think?
No.
Right. Right.
This is correct, yes. And I will explain to you, why. What is the Fermat's principle? A ray passed through the nodal point will pass undeviated.
Yes.
Yes.
Exactly. It can only be used by the can only be used the para-axial approximation. I don't understand it, but I will consider it wrong. Can be used to locate the cardinal points for an optical system.
Yes, correct.
Exactly. So we will come to that. Can be used to describe the monochromatic aberration of the optical system.
Right.
Correct. Yes, that's right. So let's mention what is meant by the Fermat's principle. The Fermat's principle is a principle which is the second name of it. It's called the principle of least time. What is the principle of least time? Meaning that if the light is traveling from point A to point B, the light will choose the shortest pathway, which will take the least time. Again, when the light travel from 2 points or between 2 points, which path did or does the light choose? It will be the path that will have the least time and the shortest distance. So let's see, for example, this video, this very short video. It will give you like an application for this principle, which is the reflection. You remember when I showed you this man with the fish, and I told you I will tell you why we cannot see in the broken lines and we can see only in the straight lines. This because the straight lines are simply the shortest lines and they have the least amount of time of the light path through it. So the light always chooses the light path that is the shortest, which will result into that the light will travel for shorter distance. So you can consider the light as lazy. So it doesn't move a lot. It will always choose the shortest pathway to do something or to move from one point to another point. And this can be explain the reflection of light. So let's see this video to demonstrate on the Fermat principle.
Applying Fermat's principle, it is easy to verify the law of reflection of light. When light does not change the medium in which it propagates, its speed does not change either. Therefore, the shortest time will correspond to the shortest distance. Which of the paths AKB, AOB, APB, or ASB is the shortest? In order to find the shortest path, we need to find the reflection of point B and then link points A and B prime. It is now clear that the shortest distance is APB.
So the light will be reflected through the point APB because these are the shorter distance. Because if we just extend it to this line, then the B dash will be the reflection of the point B. So this is like a proof of the theory of reflection, which is that the light, and also it will prove the Fermat's principle, that the light will pass through the shortest period or the shortest distance to take it in the shortest time. Okay, and as we mentioned before, that the light, when the light passes from through the nodal point of the lens, it will pass undeviated. So whether it is a convex lens or a concave lens, the light will pass undeviated when it passes through the nodal point. The monochromatic light aberration, you can see that when the white light is passing through the spherical lens, we will come to that next lecture, which is the chromatic aberration. So the white light will be dispersed into its constituent light colors. And then the light rays it will be separated into the red light, which will be deviated less, and the blue light, which will be deviated more. So you can see that the light rays can also explain the rays can explain the monochromatic light aberration, because we can draw them by rays, and these rays can show that the monochromatic blue light deviates more than the monochromatic red light. Finally, the question is asking about the cardinal points for the optical system. This will also be covered the next time. And generally speaking, we had this principle. We know that we studied that there is what's called the thick lens and the thick lens formula, in which or what's called sometimes the compound homocentric system. A compound homocentric system or a thick lens means that the different lenses are stacked after each other, and in this case it has certain rules that is not similar to the thin lens. So if we say, for example, that this is a lens and this is a lens, then to calculate the power of this system, this can be done by the rule L1 L2 equals F1 F2, which is called the Newton's formula. So the Newton's formula is applying for the thick lens or the thick lens formula. Thick lens formula, when in the human optics, we will know that the thick lens formula applies into the human eye, because the eye is considered as a thick lens because it has multiple refractive indices. It has cornea, it has aqueous, it has lens, has vitreous, and it also has cardinal points, has 6 cardinal points, F1, F2, P1, P2, N1, N2. So how did we calculate the power of the eye by what's called schematic eye? And how did we understand the optics of the eye? This is by rays also, because we apply the principle of thick lens formula into the eye. So we know that the eye has 2 nodal points and 2 focal points and 2 principal points, because it is considered as thick lens, not a thin lens. Okay. Okay, let's now check the next question. Okay, regarding thin and thick lens. An object placed at 1 meter in front of a +2 diopter spherical lens, the image is located 0.5 centimeters behind the lens. What do you think? Is true or false? Just hold on for a second, please. I will be right back. Okay, I'm back. Sorry for the interruption. Okay, an object is placed at 1 meter in front of a +2 diopter spherical lens. The image is located 0.5 centimeters behind the lens. It's meters and centimeters. So you see the trick? Okay, so this is not correct. Will be at about 0.5 meters. And for an object placed at a distance of x meter in front of a biconvex thin lens, then the magnification is inversely proportional to the x. This is correct or wrong?
Correct.
Correct, yes, exactly. So as we are approximating the object toward the lens, the more the magnification. So it is inversely proportional. In the thin lens approximation, there are 2 focal points and 2 nodal points. In the thin lens,
False.
it's false. So
false. One nodal
it
point.
has 1 nodal point and 1 focal point. So this is unlike the thick lens. So this is not true. Actually, sorry, it has 2 focal points, anterior and posterior, and only 1 nodal point. So 2 focal points and 1 nodal point.
One nodal point.
An object placed at the anterior focal point of a thick lens produce an image at the posterior focal point of the lens.
Correct.
Think again. So if we have, this is a thick lens formula, and if I have an object present at the F1 or the anterior focal plane, then the light
Thick lens.
Parallel would be.
But thick lens.
Image at infinity.
That's for the convex lens.
I think yes, it will be produced. When we have a thick lens,
like a human eye.
when we have a thick lens, then light emerging from the F1 or the anterior focal point will pass into the second one or the second lens, and then the second lens will converge the light rays to pass into the F2 or the posterior focal lens. So yes,
correct.
Yes,
Correct.
it will be correct. It will be unlike the thin lens, while the thin lens the light rays will come from the focus and will emerge parallel.
Correct.
A plano-convex lens has less spherical aberrations than the biconvex lens.
Correct.
Yes, it will be correct.
Correct.
Okay. So yes. Nice photo, by the way. Nice photo shot. Okay, so the plano-convex thick lens has less spherical aberrations than the biconvex lens of the same refractive power. This is called the best form lens. The best form lens is the kind of lens how is the lens formed in order to decrease the aberration. So the best will be what's called the meniscus kind of lens. The meniscus will be the best form lens to decrease the aberrations, followed by the plano-convex, and finally the more aberrogenic will be the biconvex and the biconcave. Okay. So here is the rule of magnification. Whenever we are placing an object in front of a spherical lens, it will produce an image. And then the magnification of this image will be calculated by the image size over the object size, or the image distance over the object distance, or the object versions over the image versions. So you can see that there is an the magnification is inversely proportionate to the distance of the object. So the more closer the object, the more the magnification, or the less the distance, the more the magnification. The more the distance,
less the
the less
magnification.
magnification. So here is, so you can see that whenever we are seeing an object, and this object subtend an angle, which we know now it's called the angle alpha at the nodal point, which stimulate number of photoreceptors. However, if we are placing a spherical lens in front of the eye, we are now seeing a larger image. So although that the image itself looks smaller, but we see it larger, because as we approximate the distance between the image to the lens, because it now subtend a larger angle at the nodal point, stimulating a larger number of photoreceptors. Okay, let's now check the next question. So this is the 6 cardinal points, and this is the how does the light ray pass through the lens. So it will not pass through the lens as it will pass through the regular thin lens, because it will pass through the N1, then it will pass from the N1 to N2, and then it will emerge from the N2. So this is how the light behaves when it passes through the thick lenses. Okay, regarding a question regarding the prisms. Regarding the prisms, which one of the following statements are true and which are false? When prescribing the prism, the orientation of the prism is described by the position of the apex.
Wrong.
Wrong.
False.
Described by the position of the base. So it's
Base.
base up, base down, base right, base left, or base in, base out. The image formed by the prism is erect and virtual. Oh, sorry, erect and real.
False.
No, virtual.
False.
It is virtual. That's correct.
Virtual.
The image formed by the prism is displaced toward the apex.
True.
True.
Correct.
Correct.
Yes, exactly. Correct. The one prism diopter deviation is equal to 0.5 degrees.
Wrong. 2.
Wrong or true?
Wrong. One prism diopter is equal to 2 degrees.
Yes, exactly. 2 degrees. Okay, and the hypertrophy of the right eye could be managed with a base up prism over the left eye.
True.
True, and this was explained. So it was explained in animation in the questions lectures. Please refer to it, because it will be discussed in all details. So I didn't want to lose time in it. So image is formed by the prism is a virtual, erect, and displaced toward the apex. So light rays deviate toward the base, while the eyes and the image are deviated toward the apex. So this is the what we need to know about the prism's rules, that the light rays come from the object, deviate toward the base. This is the principle of the prism. And then the eyes see the object displaced toward the apex. Okay, check the next question about the cylindrical lens. Regarding the cylindrical lens, which one of the following statements is true and which is false? The axis of the cylindrical lens is in the meridian in which it has no divergence power.
Correct.
Yes.
Correct, that's right.
Right.
The Maddox rod comprises of a row of powerful concave cylindrical lenses.
Wrong. False.
So what's the false thing here?
Convex. Convex. No?
Convex.
Not,
Yes,
not concave.
it's convex. The line image of point object formed by the cylindrical lens is perpendicular to the axis of the lens.
False.
Wrong.
Correct.
Wrong. So what is the correct?
Wrong. Parallel.
Parallel, exactly. A toric or spherocylindrical lens produce two line foci that are parallel to each other.
False.
False.
False, exactly. It's not
Not
One
parallel.
parallel.
horizontal and one vertical.
Yes. Depending on the principal meridian, but they are perpendicular to each other. The distance between the line foci of the toric lens is known as interval of Sturm. What do you think?
No.
Yes.
Yes,
True.
yes.
Exactly. It is
Yes, interval of Sturm.
Toric lens.
Okay, so as we mentioned before, that the cylindrical lens has no power along its axis, which act as a parallel plate of glass, like this.
Yes.
And the maximum power is 90 degrees from the axis, either convex or concave. So light rays passing like this will undergo convergence or divergence. So the image formed by a point like this, if there is a point here, and then the image formed by the cylindrical lens is in the form of not a point, but a line. This line is parallel to the axis of the cylindrical lens. The Maddox rod comprises of stacks of powerful high plus cylinders, like about 1.50 diopters. So it will convert the point source of light into a line which is perpendicular to its axis. Here is the conoid of Sturm. So it is formed by the toric lenses, in which it has a power of highest meridian and the power of least meridian. So consider this. This is the power of highest meridian will form a closer focal line. And then the power of the least meridian will form another line of the least, another line of another line, secondary focal line. The distance between both of them, the first and the second focal line, is called the conoid of Sturm. Okay, so this is like a gift question about the transposition. So this is like notation, and this question always repeat in every question, in every exam. So please check these notations and tell me which one of them are true transposition, or wrong transposition, starting with the first one.
Correct.
Right.
Right.
Exactly, correct.
Mm.
Second one.
Wrong.
Wrong.
Wrong, yes. And the third one.
Right.
Right.
Right, exactly. And the fourth one.
Wrong.
Wrong.
Exactly. And the final one.
Right.
Correct.
Oh,
Correct. Yes, that's right. So how can we do transposition? We just add the sphere to the cylinder.
Algebraic sum of the two.
Algebraic summation in order to get the new sphere. So plus 4 plus 1.25, it will be plus 525. Then
Change the sign of the cylinder.
to change the sign of cylinders, it will be minus 1.25, and we will get the perpendicular axis. So how can we get the perpendicular axis? If it is
add or subtract 90.
Add 90. If it is more than 90, then subtract 90. Okay, very good. Next question about the what is the following make use of interference, or which one of these examples are an example for interference? So polarizing filter can teach the principle of interference?
No.
False.
Are you sure?
I think right. It is right.
I think it is right, but I just forgot to bring you an image for it. Just hold on. Mm. Okay, I will check later. So polarizing filter is correct. It can use the interference, anti-reflecting coating. This is easy.
Yes.
Right.
Correct. Laser visual acuity meters, or what's called laser scanning, laser scanning interferometry. So it's called laser scanning interferometry. So it can use the principle of
Yes.
the
Correct.
interference. Pachymeter,
Wrong.
wrong, and the pachymeter also wrong.
Applanation.
Applanation. No,
Yes, exactly. Okay, so this is like the end of this lecture. So I thank you very much for your attention. I know it was a tough lecture and not easy to understand and not easy to grasp all the information about it, but I hope that it is now much more easy with this illustration. So thank you a lot, and I will see you in the next session for the human optics. I guess the next time is human optics, right? Or there will be also other topics.
Sir, I have a question.
Yes, sure.
Yeah, actually, there was a question in which it was asked, a patient with 6 cranial nerve-related esotropia
Yeah.
sees 2 images, 24 centimeter apart at 6 meters. Which one of the following is the most likely angle of squint in prism?
It is discussed.
Actually, it was explained in the...
Yeah. Go on. Yeah, go on. It is explained.
Yeah, it was explained in the video, but it was a bit difficult for me to understand. So could you please elaborate it a little bit more?
Yeah, let me just bring the question and I will explain it to you more. Do you remember at which exam or which lecture it was? Because I just want to bring the question itself to have the options. I don't remember.
MCQs.
Yeah, I know it was in the MCQs of which lesson?
Wait.
No problem. I will just
7.
7.
Yeah, 7.
Which is 7? 7 lesson or 7 question or 7 what?
7 geometric optics.
Okay.
In the MCQ for physical and geometric optics.
Okay, I got it.
In 1 hour.
Yeah.
1 hour, yeah.
Okay. So the strategy for the optics is difficult. This is my voice. I just want to clear or to point to something. Please, I don't like to talk about that, but please, if you ever had anything from my lectures, like any screenshots or any recordings, please, this is just for your personal use. I know that you know that already, but I hope that you understand or appreciate the extreme hard effort that have been exerted into these lectures. I'm trying to find this question, but unfortunately I can't. If you just can send me a screenshot for this question in the WhatsApp group, and I can discuss it like the next time if you want.
Okay, sir. Okay.
Just for the sake of time. Okay, but just remind me or just send me to send to the group. Okay.
Okay.
Okay. Thanks a lot for your attention and see you the next session. Okay. Goodbye.
Thank you, sir. Thank you, sir. Thank you, Ahmed.
Thank you very much.
Thank you.